Hey, 7th graders, we're going to be talking about inequalities today. And yes, they've divided this into several sections, but you've already learned almost all of this as you did equations. So let's start by solving an equation, and I just want to show you the difference. And just to note, I will be erasing this whiteboard, so just be prepared to pause and take screenshots if that's how you take notes or whatever you want to do. But anyway, okay, so let's do 2x minus 7 is equal to negative 4. Okay, so we draw our line down the middle and we solve an equation. Now, we'll get to that. Okay, so let's just go ahead and do that. I'm going to add 7 to both sides. So this is a review for some of you here maybe that's useful. And we end up with 3 and divide by 2. Divide by 2. And we end up with x is equal to 3 halves. Or let's go ahead and call this 1 1/2. Okay, so what we have here is we have an equation, and it's called an equation because of the equal sign. Remember, equal equation, okay? An inequality is solved the exact same way with one small exception we'll get to in a little bit later, except it does not have equal signs. It has greater than, less than, greater than or equal to, less than or equal to signs. Okay? So so there's only two things that you need to know that you shouldn't already know by now to solve inequalities. One we'll get to later, but the other is to graph it. Okay, so let's just graph, just so you can compare, let's graph the solution of an equation of x equals 1 1/2. Well, here's 0, here's 1, here's 2, here is 1 1/2. Okay, we'll call this 1 1/2. Okay, so the only solution that fits into x right here that works is 1 1/2, and you see this is a closed circle. This is how you're used to seeing it, a dot that is at 1 1/2. So we don't bother graphing this because a graph is sort of unnecessary. The only solution is there's one solution that makes this equation up here true, and it is positive 1 1/2. So what's the difference? Okay, so let's just, I'm going to erase, so take a screenshot if you want to. So there is only one. Now, when we get to inequalities, okay, when we get to inequalities, we can solve them the same way. We solve them by doing the opposite operation, just like equations. We're trying to isolate the variable. And then let's say we come up with x is greater than or equal to, so that's what that line means, or equal to 3. So once we've solved it, so let's pretend we just solved an equation. I'm doing this for time. Now we need to know how to graph it. Okay, so x could be equal to anything greater than or equal to 3. So I want you to pause it and think about what that graph might look like. Any number greater than or equal to 3 will work in this inequality. Okay, so we have a 0, we have a 1, 2, 3. Now, 3 does work because we have the equal then sign. So the two different ways that we write these are, if there is this line, it's a closed circle, okay? If by chance there wasn't this line, okay, then we would have an open circle, just like that. So not including 3, but all the numbers greater. And so we just kind of draw this like filled in line with a filled in arrow, and there's an infinite number of solutions that are greater than 3, because this could all go to 1 million, 1 billion. This actually goes all the way to what we call positive infinity, and that's a terrible infinity sign. I haven't drawn infinity in a while. Positive infinity. Yeah. There, that's better. All right. And if it were less than, so if we just change this, if we just change this to less than, so x is less than 3, then, oh, my eraser's not working the way I want it to. Then we would still have this line, but now we're talking about all the values less than 3, right? 2 is less than 3, 1 is less than 3, 0, negative 1, all the way on to negative, let's see, infinity. All the way to the negative infinity. And you don't have to write negative infinity. I'm just showing you that there are an infinite number of solutions that would satisfy an answer of x is less than negative 3. Okay, so we're going to do that, and we're going to graph a whole one. But I want to show you the one exception, and that is if I have a negative, if I ever, and I want you to write this on the top of your paper because you will need to remember this, if you ever multiply or divide both sides in order to solve it by a negative, you switch the sign. So I'll show you what I mean. Let's say I have a negative 2x is greater than 8. Okay, so this is my inequality I have to solve. In order to get x by itself, I'm going to divide by negative 2. Well, I just divided by a negative on both sides. So what I end up with is I have to flip this sign. So this sign comes down and it flips. It goes the other way. 8 divided by negative 2 is negative 4. So the solutions that go that negative 2x, negative 2 times any number that is less than negative 4 will give me a value that is greater than 8, right? So let's try negative 2 times negative 4 is 8. Is 8 greater than 8? No, and that is why we don't have the equal, the line right here, okay? But negative 2 times negative 5 would be negative 10, right? And that would begin to work. In fact, negative 4.5 would be greater than. Okay, so the way we graph this is we have our 0, we have our negative 1, negative 2, negative 3, terrible 3, negative 4. So anything less than, don't forget open circle because we do not have the line here. So since we do not have the line, it's this open circle. And then it's less than, so anything less than goes left, anything greater than goes right, and we can just kind of make our filled in line. And on big ideas, it should be very obvious. It'll look like your choices will look like this. Like that's closed circle with an arrow, and then there'll be one that looks like this, and that's open circle. And then they'll have they'll probably have just a dot because that's just equal. And then they'll have a closed that goes this way and an open that goes this way. And you'll just drag those onto you'll just drag that. So on this one, I would have dragged this one down here on negative 4, and it would have filled in. So you'll see when you get to it. There will be some parts where you have to write them, and you just need to remember what you learned about inequalities, where we have the terms, things like at most, right? So I have at most $20 in my pocket, which that means that would be less than or equal to. And remember, this is at least. It is at least 5 miles to school. So at least would be it's 5 miles or greater than or equal to. So if you have to write one, just remember some of these keywords: at most, at least, greater than, less than, and hopefully you got that chart from when we did that. So yeah, you should be able to see examples in your ebook. I wanted to make this short because, they've broken these sections up. I think it's easier to explain this as a whole. So let's just review really quickly. You can, if you've got this, you can turn this off. But just as a review, apparently that eraser only works when I hit the second button. Okay, so just remember, the main two things we figured out is that when we have an equation, x equals 2, it is just a dot. The only thing that works for in the example x equals 2 is just 2. 2 is the only solution. However, x is greater than 2, okay, includes all the solutions that are greater than 2 but not including, and when we put not including, we do an open circle. If we had x is greater than or equal to 2, then we would have the same thing with a closed circle. Okay, so the two things that you needed to learn besides just solving an equation, we solve these just like an equation, the two things you need to know is how to graph, and then the fact that if you multiply or divide by a negative, you flip the sign. All right, come see me with questions. Take care.